Solve radical equations. Here we have 2x equals square root of 28x plus 29 and then minus 3 on the outside. The first thing we have to do when solving radical equations is isolate the radical. We're going to do that by adding the 3 over. So we have 2x plus 3 equals the square root of 28x plus 29. Now we can get rid of the radical by squaring both sides. And when we square the left-hand side, we get 4x squared plus 12x plus 9, and that's equal to 28x plus 29. Now we just solve this as if we're solving a quadratic. So we're going to minus the 28 over, the 28x over. We have minus 16x, and then we're going to minus the 29, and we get minus 20 equals 0. We can factor out a 4, and we get x squared minus 4x minus 5 is equal to 0. And then we can factor the quadratic. We have x minus 5 and x plus 1 equal to 0. So x equals 5 and x equals negative 1. Now when we square both sides of an equation, some bad things can happen. For example, we can take a very simple example. We can say 2 equals negative 2, and that's clearly a false statement. 2 does not equal negative 2. But if we square both sides, then we take a false statement and we turn it into a true statement. So squaring both sides of an equation can have some really bad consequences. Because of that, we have to plug 5 in, and then we have to plug negative 1 in to check to see if we made a false statement into a true statement. So let's plug 5 in. We have 2 times 5 is 10. That's equal to the square root of, let's see, we have 28 times 5, that's 40. Looks like 169 minus 3. We have 10 equals, that's 13 minus 3. So we have 10 equals 10. So 5 is a good solution. 5 is a good answer. Let's plug negative 1 in. We have negative 2 is equal to the square root of, let's see, we have negative 1 times 28 is negative 28, plus 29 is 1, and then minus 3. We have negative 2 equals 1 minus 3, which is negative 2. So negative 1 is a good answer as well. Solve radical equations. We're going to start this one the exact same way by minusing 8 and isolating the radical. So we minus 8, we get 4 equals the third root of x minus 2 squared. And then we can raise both sides to the third power. We have 64 is equal to x minus 2 squared. 64 is equal to x squared minus 4x plus 4. And then we'll have to minus the 64 over. We get 0 equals x squared minus 4x minus 60. Now we need factors of 60 that add up to negative 4. 0 equals, we have x, let's go with minus 10 and x plus 6. So x equals 10 or x equals negative 6. Let's test these out. We have 12 is equal to the third root of, let's plug 10 in, we get 8 squared, and then plus 8. So we get 12 equals the third root of 64 plus 8. The third root of 64 is 4, and 4 plus 8 is 12. So 10 is a good answer. Let's test negative 6. We have 12 equals the third root of, plug negative 6 in, we get negative 8 squared, that's 64, and we're right back to where we were before. So negative 6 is a good answer as well. Solve the radical equation. In this one, the first step is to just square both sides because there's really no way to isolate the radical because there's 2 radicals in this one. So we're going to square both sides. On the left-hand side, we get x plus 1. And on the right-hand side, we need to FOIL this together. So we'll create another one. So we have 1 plus square root of 2x minus 12, and now we're going to FOIL. So we get 1. And then plus, the outside is the radical, and the inside is the radical, so we have 2 of these. So we have 2 times the square root of 2x minus 12. And then on the last, the radicals go away, So we have plus 2x minus 12. Well, now we can isolate this radical right here, and we can start by minusing 1 from both sides, and then minus 2x over, we get negative x, and add 12, so we get plus 12. And that's equal to 2 times the square root of 2x minus 12. Now the radical really isn't isolated because we have the 2 here, but if I divide by 2, I'm going to get a negative 1/2, and I want to try to avoid fractions. So instead of dividing by 2, let's just square both sides, and we'll remember to square the 2 as well. So we have x minus 24 x squared minus 24x, and then plus 144, and that's equal to 4 times 2x minus 12. Well, we have x squared minus 24x plus 144 is equal to 8x minus 48. Now we have x squared minus 32x plus 192 is equal to 0. The factors of 192 that add up to 32 are negative 8 and x minus 24. So x equals 8 or x equals 24. But we have to test those values because we squared both sides a couple times, so it could turn what's a false statement into a true statement. So let's test 8. Now we're going to go back up to the original, so let's kind of get rid of what we wrote here so we can see the original equation. 8 plus 1 is 9, so on the left hand side we have 3. Now we have 1 plus the square root of 8 times 2 is 16, 16 minus 12 is 4, 2 plus 1 is 3, so we have a good answer. When we plug 24 in, we get 25 on the left side, so square root of 25 is 5. And then we have 1 plus the square root of 48 minus 12. 48 minus 12, and that is going to be, let's see, we have 1 plus the square root of 36. We have 1 plus 6, that's 7. See, we needed this to be a negative 6 in order to get negative 5, so that's where squaring caused some problems. So we're going to indicate this is a bad solution by crossing out the 24. On this one, we can isolate the radical, so let's minus 6 over. We get 2x minus 6 equals the square root of 20x plus 36. Now we can square both sides. We get 4x squared minus 24x plus 36, and that's equal to 20x plus 36. Well, we can subtract 36 from both sides, and we can minus 20. So we get 4x squared minus 44x equal to 0. And we can factor out a 4x. So we get x minus 11. So the zeros are x equals 0 and x equals 11. Let's test 0. When you plug 0 in, you get 0 equals 6 plus 36, and that's 0 equals 6 plus 6. And of course 0 does not equal 12, so 0 is a bad solution. Let's test 11. We get 22 equals 6 plus the square root of, let's see, 20 times 11. That's 220, so we get 256. We get 22 is equal to 6 plus 16, and so 22 equals 22. 11 is the good answer, and 0 is the bad answer.